Hey, hi folks. I basically went over the properties of log today in class. And the problems that you see right now on the screen are your homework problems. And I'll go through some of the problems here to give you a little bit of help completing your homework. As far as I can remember, the ones circled in red are the problems that I have already covered in class. So I will go over some of the problems that are not circled. Okay, first of all, 15 is kind of too easy, so I'll just skip over this one. Okay, the answer to this one would be log base 3 x minus log base 3 and 9. And again, this can be written as log base 3 x minus 9 is like what? It's 3 squared. So using the power property here, this power can be taken in front of the log. So you can write this as log base 3 x minus 2 times log base 3 and 3. So if you find these two numbers being the same, then this is just simplified to 1. So this is log 3 base 3x minus 2 times 1. So that's 2. Okay, so that would be your final answer. Okay, next one. Use the values given below to approximate the value of each logarithmic expression. Okay. Okay, let's look at 18. Log base 2, 35. Okay. So we have, let me see. We have this log with base 2 and this log with base 2 and another log with base 2 here. So we have to rewrite 35 as a factor of these numbers, 7, 5, and 3. So 35 is just log base 2. 35 is 7 times 5. So using log property, we can separate this log into 2 logs. Okay, base 2, sorry about that. So, log 2, 7 plus log base 2, 5. And according to this table, log base 2, 7 is 2.8074 plus log base 2, 5 is 2.3219. You add these two together and it's going to be your final answer. Okay, let's look at, let me see, 21. Log base 4, 60. Oh, my computer's acting up a little bit. Log base 4, 60 is equal to, okay, 60. Let me see. I have this one, base 4. This is log base 4. So let me use those two. So I'm going to express this as, okay, product of numbers that are made by 5 and 3. So 60 is like 30 times 2, but we don't have log base 4 and 2 here. So I'm going to express that as 20 times 3. But then 20 can be also written as 4 times 5. So let me further expand it like this. 4 times 5 times 3. So now we can separate the logs. Log base 4, 4. So multiplication can be converted into plus. Log base 4, 5 plus log base 4, 3. So this is just 1. And then log base 4, 5 is right there. That's 1.1610, 1.1610 plus log base 4, 3. It's 0.7925. So you add them all together, and it's going to be your final answer, okay? Next, what am I going to do? 24. Let's look at 24. Log base 10, 0.0083. So this can be written as log base 10. We got this one. So let me express 0.0083 as 8.3 times 10 to the what power? 1, 2, 3, -3. Now you can separate this log into 2. Log base 10, 8.3 plus log base 10, 10 to the power of -3. This power exponent here can be sent in front of this log. So this comes down to, okay, this first one is 0.9191, so 0.9191. And then you took out that -3 in front of that log. And then what we have left over is log 1010 here. So same number, okay, 10 and 10. So this is just 1, okay? So your final answer is 0.9191 minus 3. So calculate this, you'll get your answer. Okay. All right, what else is there? Rest of this stuff are kind of easy, so I'm going to skip over to next block. Okay, this one. Write each expression as a single logarithm, then simplify if possible. I said in class 29 to 32 is too easy, so I'm not going to do them. But instead, let's look at 35. 35 is also easy. Log base 7, 3x minus log base 7, 9x plus log base 7, 6y. So they got the same base here, base 7, base 7, base 7. So you can combine those 3 logs into a single log with base 7. Okay, first of all, this is minus, so you take 3x and then subtract it with subtracted by 9x. And then this is plus, so multiply 6y to this one. Now you can simplify this. So let me cancel these two. X's also cancel. I can cancel denominator 3 and this 6. So that's 1, that's 2. So the only thing that is left over after canceling all of these is 2y. So this is simply comes down to log base 7 2y here, okay? Let me look at, we did 37 too in the class. So I'm going to do 38. That's 7 log base 3. Oh, my computer is acting up again. Log 3y minus 4 log base 3 x. Okay, I said in class before you combine these logs, the coefficient, okay, this 7 and 4 should be removed. How? You take this thing back here as an exponent. You do the same thing here. So this is same as log base 3 y to the power of 7 minus log base 3 x to the power of 4. Now it's free of any number in front of the log, so let's combine it now. Log base 3 y to the 7th over x to the 4th. Okay, that's all. That's nothing to be simplified. Let me do 39. Okay, next. Okay, let me just solve it directly here. Let's get rid of all these numbers in front of the log. So first one is log base b m to the power of 4 plus log base b, okay, n to the power of 1/2 minus log base b 2p. Make sure you put a parenthesis here because this exponent will be applied to the whole thing here, 2p. So it's part of 3 here. Now let's combine the logs. Okay, log base 6. I got m to the 4th. This is plus, so you have to multiply n to the power of 1/2 here. And then this is minus, that's a what? Division here. So put this as your denominator, 2p whole thing cubed. If you want to rewrite this, you can calculate that cube there, so it becomes 8p cubed. Okay, and if you don't like this rational power, you can convert that into a what? Power of 1 over 2 is same as square root, so that's square root of n. Okay, you can write it this way also. Okay. All right. 40 is very similar to 39, so I'll leave it up to you. Okay, and 42. Okay, 2 plus 4 log base 3 x. So basically you can get rid of this number as before by moving that over to this over here as an exponent to x. And if you want to simplify this one by combining the log, this one does not have any log, but you can convert that into a log. How? Okay, we have a log base 3 here, so I can have 2 times log base 3 and 3. This is basically 1. And then we have this one. Make sure you move this number here as an exponent, move this number as an exponent. So you end up with the single log here. Let me just write this thing down first so that you don't get confused. That's 3 squared plus log base 3 x to the 4th. And then combine the log. Combine these two logs with base 3. 3 squared is basically 9. So 9, that's plus. So that's 9 times x to the 4th. Okay, that's all. Okay, let's move to the next block. evaluate each expression. Oops, let me erase that. This circle got messed up here. So anyway, one of the log properties that look a little bit awkward or strange is something like a to the power of log base a x. In that case, I said if this base and as log appears as an exponent here with the same base a, then this simply comes down to just x. Okay, this is an exponential form, and if you know if you rewrite that as a logarithmic form, that's basically okay. This is the base, so you're going to have log and write this base a log to the power of, okay, this is the power here. So this is where the power appears. So log ax, that power is equal to this x. So this x comes to this part here. So basically what we have is log base ax is equal to log base ax. So this expression and this expression are basically equivalent expressions. So this is totally legitimate, okay? So this one holds. So when you look at this kind of problem, just look at this base and this base. And if they are same, your answer is just x. So in the class today, I said, okay, look at this one. And this base and this base are basically the same. So this answer is just 8. Same thing applies in 44. 9, 9, they're same. So that's 2. Okay, for something like this, you send this power in front of this log. So that's 5 log, oops, log base 4 and 4 here. So this is just 1. So that's 5 times 1. So that's just 5. Okay. 47, we did it in class. 48. That's 5 to the power of log base 5, 7, plus log base 3, 9. So this part comes down to 7, and this part, okay, is log 3 base 3, 3 squared. So this can be sent in front of this log. So that's 7 plus 2 log 3, 3, but log 3, 3 is just 1. Okay, so 7 plus 2 is 9. Okay, easy peasy. This one, piece of cake, 50, also piece of cake. This one also. They look all similar to me. Okay, let's just do one more, 54. They're all the same to me, so you can easily do it at home. Okay, 54. Log base 2, and it says 1 over 8. 1 over 8 is basically 2 to the power of negative 3. And the second part, I got this base 4 and this base 4 in this log in the power. So that is basically equal to 7. Okay. So this number can come in the front. So this is negative 3 minus 7. So the answer is negative 10. Okay, let's go to the next block. solve for x and check your answers. Justify each step in the solution process. Okay, I said today, one important fact that you have to remember for log equations is that you must check your answer, okay, at the end, because for something like this, depending on the value of x, there's a chance that this number can be either 0 or negative. But in a log, this number should be always positive. If this is 0 or negative, this log is just undefined. So that means the problem itself is undefined. It's not solvable, okay? So you have to always check your answers, and if get into that kind of situation where this number becomes 0 or negative, you have to throw away that answer. That's no good, okay? So I looked at those. I looked at that exact case happening with 62. Okay. Let me see. Let me do two of the questions here that were not covered in class. Let's look at this one, 59 and 61. 59. Should I do this thing too? Let's do these three, okay? 57. Log base b x squared minus 15 is equal to log base b 6x plus 1. Okay, it basically says these two logs with the same base b are equal to each other. So what that means is that this part, x squared minus 15 and 6x plus 1 should be equal to each other, so that the whole equation of the left-hand side and right-hand side is equal to each other. So this simply comes down to x squared minus 15 is equal to 6x plus 1. I'm going to move everything to the left-hand side. X squared minus 6x minus 16 is equal to 0. Can we factor this thing? Yes, it's x minus 8 times x plus 2 is equal to 0. So x is either 8 or negative 2. So as I said, you're not done here. You have to check your answers, okay? So plug in 8 here, see what happens. So when you plug in 8 here, that's 64 minus 15, so you end up with a positive number, so there's no problem. Here also, okay, that's 48 plus 1, that's a positive number, no problem. But what happens with negative 2? This becomes 4 minus 15, so you end up with a negative number here. And also here, when x is negative 2, you end up with negative 11 here. So it doesn't make any sense, because we cannot have a negative number inside the log. So this negative 2 should be thrown away, okay? That's not a good answer. So the only answer is x is equal to 8. Okay? Okay, 59. Okay, 2 log a x plus log base a 2 is equal to log base a 5x plus 3. Okay, for something like this, you should have a single log on the left-hand side and single log on the right-hand side. Then the problem becomes something like in 57, okay? So let's combine these two logs. Okay, what should I do? I have to get rid of this number first, move it backwards here as an exponent. So when you combine it, it becomes, okay, let's write one more line here, x squared plus log base a 2 is equal to log base a 5x plus 3. Now combine these two logs together. So log base a, that's a plus, so you have to multiply these two. So that's 2x squared is equal to log base a 5x plus 3. Since you have the same log, okay, log base a, this comes down to 2x squared is equal to 5x plus 3. And let's rearrange it. So 2x squared minus 5x minus 3 is equal to 0. Now you can factor this thing. So 2, 1, 1, negative 3 here. So it's going to be factored. So it's at 2x plus 1, x minus 3 is equal to 0. So x is negative 1 over 2 or 3. Okay, and erase this thing. Okay, is there any bad answer here? Yes, there is. Negative 1 over 2. When you plug this thing in here, what happens? There's a negative number inside log. So this is no good. Okay? Throw this thing away. 3 is perfectly okay because it's not going to get you in that kind of problem where you have a negative number inside the log. So the only answer would be this 3. Okay, 61. 61 looks very similar to 59. So I'm not going to write down the problem here. I'm going to just move this thing here. And it's got log base 3 and log base 3. So combine these two logs together. So you end up with what? 5x squared. On the right hand side, so I just took out log with base 3, okay, right away because I have the same log on the right hand side. So this 5x squared must be equal to 14x plus 3. So this is 5x squared minus 14x minus 3 is equal to 0. So you can factor it like this, 5, 1, 1, 3. This has to have a minus sign in front of it. So that's 5x plus 1, x minus 3 is equal to 0. So x is negative 1 over 5 or 3. So if you put in this negative 1 over 5 into this x right there, it makes this number inside the log negative. So you take this thing away. Okay, 3 is just fine. Okay, it's not going to get you in that trouble. So this is your only answer. Okay, let's go to the next block. State whether each equation is always true, sometimes true, or never true. Assume that x is a positive real number. You just use properties of log to prove the left-hand side is equal to the right-hand side. So for example, like 65, the left-hand side, log x squared, can be rewritten as just using log property. This power can be taken in front of this log. So that's same as 2 log x. So basically, this is what you have on the right-hand side. So this is always true, okay? This 66 must be always true too, because log minus log basically equals log this x divided by 5. So that's always true. 66 is always true. 67, have you seen something like this? Don't get confused with this, okay? I think I covered this thing in class 2, okay? The one that we saw as a property of log is this one, log base a times, this is a common log with base 10, so let's not write the base here. Log m minus log n is basically equal to log m over n. Don't get confused by this. This is not, okay, this is wrong, okay? This is not log m over log n. This is not that. It's just, it's not this, but it's this, log m over n. You have to have a single log, not two separate logs. So this cannot be true. This cannot be true. So this is basically what this thing says. So this is what? This is never true. Okay, same thing with this too, okay? This cannot be true. Don't get confused with this. That's never true. We covered all of these three already in class. So this is what? 1/2 power moving this way means it's a square root on x. So this is always true. Is this always true? What you can do is this. Okay, for something like, we did it in class, but let me do it again, just in case you forgot how to do it. So log 12x, so it says this thing is equal to 12 log x, but let's move this number back here as an exponent. For these two logs to be the same, this part 12x and this part x to the power of 12 must be equal to each other. So x to the power of 12 is equal to 12x. Can these be equal to each other? What's the condition for them to be equal to each other? I guess x is 0. 0 to the power of 12 is 0. And 12 times 0 is 0. But you cannot have 0 inside the log, so you cannot have that. And in fact, it says assume that x is a positive real number. So when you plug in a positive number here, is there any number that makes these two expressions together? I don't see any, okay? When x is 1, this part, left-hand side is 1, the right-hand side is 12. So there's a big difference. If x is 2, what happens? This is an exponential, that's not exponential, but that's a what? A polynomial function with power 12. So that's 2 to the power of 12 is a huge number here. But if you plug in 2 here, that's only 24. As you increase the number, okay, this one gets dramatically bigger, okay, than this one. So these two cannot be equal to each other. So there's no number, okay, no number exists that makes, these two expressions same. So it can never be the same. So this is never true. Okay. 71. Let's combine these two. That means log base 3 x squared. And that is equal to log base 3 and 2x. So I got log base 3 on the left-hand side, log base 3 on the right-hand side. For them to be equal to each other, x squared must be equal to 2x. And let's solve this equation, so x squared minus 2x is equal to 0. So x times x minus 2 is equal to 0. So x is either 0 or 2, but it says assume x is a positive number, so this cannot be our answer. So this says when x is equal to 2, the expression on the left-hand side and the expression on the right-hand side will be equal to each other. Is that true? Just plug in 2 into this x and confirm that they are the same. Okay. So what do you get? Log base 3, 2 plus log base 3, 2 is equal to log base 3, 2 times 2. So if you combine these two logs together, that becomes log base 3, 2 times 2, okay, is equal to log base 3, 2 times 2. So they are same, okay? So when x is equal to 2, this expression holds, but if you plug in any other value into x, it's not going to hold. So this is sometimes true. All right, let's move to the next block. So challenge question, we did 72 already. Okay, I said this looks a little bit complicated, but it's not really hard. So I told you to try 73 at home. Okay, so when you look at this one, I said look at this expression inside this big bracket, okay, as a chunk. So this is like log base 6 and then something is equal to 0. So that means this bracket is equal to 6 to the power of 0 is basically this one. So 6 to the power of 0, so that's basically 1. So what was in the bracket? So log base 5 log base 3x is equal to 1. That's basically what we have. Now use the same method here. You view this thing as a something, a chunk, okay? So this is basically what then? You take this base 5 and raise it to this power, which is 1, will give you this value right there, which is log base 3x. Now just convert this log expression into a exponential form. So take this base 3 to the power of, this is basically 5. 5 will be, okay, if you take this number and raise it to the power of 5, you get x. So x is 3 to the power of 5. Okay, calculate this number. 3 to the 4th times 3. 3 to the 4th is 9 times 9, so that's 81, times 3, so that's 243. Okay, this is going to be your final answer. Okay? Okay, that's it for today. So hopefully this will help you with your homework. Okay, see you guys later. Okay, bye bye.